Hello everyone, my name is Gulbarshin Mukasheva, PhD, Senior Teacher of the Department Epidemiology and Biostatistics. Today I will present a lecture on experimental researches in medicine. In this lecture, we will discuss the main types of experimental research, their features, advantages and disadvantages. What is experimental design? Experimental design is a research plan that allows the researcher to make accurate conclusions about the relationship between independent and dependent variables and to test the hypothesis. It helps organize the study in a way that provides valid and reliable results. Experimental researches are a type of research in which the independent variable factor drug treatment strategy is manipulated to observe its effect on other dependent variables, disease outcomes, recovery. An experiment is a set of observations conducted under controlled conditions where the researcher manipulates the conditions to determine the effect on the outcomes. Let's look at the advantages and disadvantages of experimental studies. Advantages: maximum control, high internal validity, helps to investigate cause and effect relationships, provides the highest level of evidence. Disadvantages: ethical issues, complexity in implementation, sometimes unnecessary if other study types can answer the question. In this slide, the plus side shows strengths and the minus side shows the main limitations. Types of experimental research: pre-experimental design, true experimental design, and quasi-experimental design. This slide shows the comparison of three experimental research types. We can see the difference between a pre-experimental, true experimental, and quasi-experimental designs. Pre-experimental designs have no control and no randomization. True experimental designs have both control and randomization. This makes them the most accurate. Quasi-experimental designs have control but no randomization. This comparison helps us understand how much control each design provides. Types of true experimental research. There are 6 types of true experimental research: post-test only design, pre-test, post-test design, Solomon's 4 groups design, factorial design, randomized block design, crossover design. The true experimental design is the gold standard in medical research. It includes all 3 key elements: manipulation, control, and randomization. The schematic sequence of an experimental study. You can see in this page scheme of experimental study. Here R is random selection, X is independent variable, O is dependent variable. First type of true experimental research is post-test only design. This design uses random assignment but does not include a pre-test initial measurement. Scheme: random assessment first. After that we will divide into 2 groups, experimental group and control group. Experimental group will conduct treatment, and after that post-test. Control group without treatment, we will just measure post-test. This design evaluates the effect of the intervention based on post-test results only. Next design is pre-test post-test design. This design allows measuring the initial condition pre-test and assessing the change after treatment post-test. This helps measure the change that occurred after the intervention. The first observation is a pretest, which shows the initial condition. Then the experimental group receives the treatment and both groups are tested again in the post-test stage. This allows researchers to compare the difference between pre- and post-test scores. Next design is Solomon's four-group design. The Solomon's four-group design is another type of the true experimental research. It combines the features of both the pre-test, post-test, and post-test only designs. You can see four groups here. Two groups take a pre-test and two don't take a pre-test. Two groups receive the treatment and two groups don't receive the treatment. This design helps determine whether the pre-test has any influence on the final results. It's one of the most powerful designs for checking both treatment effects and testing effects. Next, factorial design. A factorial design is used to study the effects of two or more independent variables, factors. In this slide shows a practical example of a factorial design. The main independent variable is the mouse Rhine solution. There are two types, chlorhexidine, saline solution. These two solutions will be compared to see which one is more effective. And we will compare this by hours. Every 4 hours, every 6 hours, every 8 hours. This time hours will be factor for this treatment. At the end we will find maybe saline solution every 6 hours more effective than every 8 hours or every 4 hours. Like this we will find. Next, randomized block design. A method of dividing a study into homogeneous subgroups, blocks it means, based on characteristics that affect the experiment but are not the factor being studied. For example, on this table each block represents a combination of different variables. Here, different drugs and different conditions such as primary diabetic or renal hypertension. This way we can study main effects and interaction effects between the variables. At the end we will find which drug is more effective for which type of hypertension. For example, maybe drug A will be more effective for diabetic hypertension. Drug B will be more effective for renal hypertension. Drug C maybe will be more effective for primary hypertension. Next, crossover design. Each participant receives all treatment at different time periods. This allows each participant to serve as their own control group. Crossover design is a type of experimental design in which the same participants sequentially receive several different interventions, for example, treatment A followed by treatment B, with a washout period between them. Here two groups in this table, and first group will use first medicine in first stage. After some time they will change their treatments. Next, quasi-experimental research. Unequal control group design, interrupted time series. In real-life research, it's not always easy for a researcher to randomly assign participants or match them equally. Such difficulties may lead the researcher to relax some of the strict requirements of a true experiment. For example, sometimes the researcher may not include a control group at all, or even if there is a control group, participants may not be randomly assigned to the experimental and control groups. In such cases, the study is called a quasi-experimental design. In this case, the control group is usually referred to as a comparison group. Non-equivalent control group design. This is one of the most commonly used and fundamental research designs in healthcare. This design resembles a pre-test post-test experiment with a control group, but with one key difference: participants are not randomly assigned to groups. The researcher simply selects two similar available groups. For example, Group A, patients attending diabetes hospital A, Group B, patients attending diabetes hospital B. The researcher applies the experimental intervention only to one group, the experimental group. The comparison group either receives no intervention or an alternative intervention. Interrupted time series. Interrupted time series. In this type of study, the researcher observes the effect of the independent variable in only one group. No control group is used. Data are collected multiple times before and after the start of the experiment. For example, the researcher measures the pain levels of patients with back pain for 3 weeks, then teaches them specific exercises. In the following 3 weeks, pain levels are measured again. These results help determine whether the experiences have an effect on reducing pain and whether the effect is maintained. Advantages. Data are collected both before and after the effect of the independent variable. Participants serve as their own control. This method allows for precise assessment of whether the variable caused the change. Thank you for your attention.